Not in the playful way.
Okay, guys. First question says, based on the given information, what can you conclude and why? They'll tell you that angle P is congruent to angle T, and they tell you that PR is congruent to RT. What else do you know about this picture? It's not given to you. Well, what we know is that these angles are congruent. QRP is congruent to angle SRT. Why? Why are they congruent, Gentry?
Oh, just because they're vertical.
Now that I know that, what reason can I use to say that the triangles are congruent? No.
Oh, sorry, inside angle.
Angle, side, angle. And I have to choose the one that has the right pairing. Don't pick the one that gets them mixed up. So it says PQR and RTS. Is that correct? Is A correct? No, it's got them mixed up. We know those are wrong because it's the wrong reason. PQR and TSR. Answer to number 1 is B. You have to have the right reason, and you have to have the right letters in the right order. Question?
So on an isosceles triangle, the two bottoms are
Yes.
the two bottom angles.
But they have to tell you it's isosceles.
They didn't tell us that it was isosceles. So,
Not in this one.
so you can't. I didn't really know if the angle R was congruent to angle R.
It is because of vertical. Vertical angles occur when two lines intersect, and every single time two lines intersect, vertical angles occur, and they're always congruent. You don't have to wait to be told. You go ahead with that one, okay?
Okay, so since they intersected, it was right.
Yes. Number 2 says, name the theorem or postulate that lets you conclude that ABD is congruent to CBD. Okay, they've given you two angles that are congruent. And what do you know about these two angles? They're also congruent. So I've got an angle, and I know that's congruent because of reflexive property. So which reason do I use?
Sass.
No.
Angle,
Angle, side.
Right.
Number 3.
Side angle.
Supply
side
the missing reasons to complete the proof. Given that angle A is congruent to angle D, let's mark that. And that AC is congruent to DC, let's mark that. Prove that's congruent. Okay, first thing, angle A is congruent to angle D, AC congruent to DC, given. Yes. Angle BCA, that's this angle here, is congruent to angle ECD, that's this angle here, because vertical angles are congruent. True. Triangle BCA is congruent to triangle ECD by what reason? What reason can I say that the triangles are congruent?
angle side.
Angle, side, angle. There's an angle, a side, and an angle. An angle, a side, and an angle. Now, how then, what's the next reason to say that BC is congruent to EC? CPCTC. What'd you call that, Jonathan? There you. Could you say it just one more time, a little bit louder? Okay, so this is answer choice C.
Actually, what you said.
4.
Very funny.
Now call her. Tone it down. R, S, and
Well,
T
at least I'm not acting stupid this time.
are vertices of one triangle.
No offense.
E, F, D are vertices of another. R is 50. S is 100. F is 50, D is 30, RS is 4, EF is 4. Are the two triangles congruent? Are the two triangles congruent? What's the missing angle in this one? 30. I'm going to write it here. What's the missing angle here? 100. Now the question is, does the side that they have congruent to each other fall between the same two angles? The triangles don't have to be oriented the right way. They can be twisted, turned, flipped, anything. But that side that's congruent must fall between the same two angles in both triangles. Does that happen? The side that's 4 falls between the 100 and the 50 in both. So we're at what? Question 4. Answer here is A. The answer is yes, by angle, side, angle. And what's congruent to RT? Well, it's the side that's between the 50 and the 30, which is FD from the other picture. Number 5, it says if BCDE is congruent to OPQR, then CD is congruent to what? The way they name these is very important. If they call CD, then which two correspond in this picture? PQ.
Okay.
Number 6. In the airplane, the paper airplane, A, B, C, D, in E, F, G, H, B is congruent to BCD. 90, 90. BAD is 124. Find GHE. You've got to find that angle. Now these two are congruent. So if you can find D, you know the answer to GHE. What shape am I working with there? How many sides does it have? There's 4. What is the total number of degrees in a 4-sided figure? 360. You've got two 90-degree angles and a 124. Add 90, 90, and 124 together. What do you get? 360 minus 90, 90, 124 gives me this number. What did we say? Somebody said really loud and clear.
204.
Thank you. I think you're right. So what happens when you subtract that from 360?
156.
I think it's 304. So my answer here is 56 degrees. Number 7. 7 says P N M is congruent to what angle from this picture? What'd you put? Number 8, given triangle QRS is congruent to TUV, and that QS is 4V plus 2 and TV is 5V minus 6, find QS and TV. QS and TV must be congruent because they are corresponding letters in this congruent statement. So 4V plus 2 is equal to 5V minus 6. What do we do next? So I got V to be 8, but that's not what they're asking for. They're asking for the actual length of those sides. So I got to come back up here and say 4 times 8 plus 2. What's that going to be? 32, 33, 34? Should I get the same thing on the other one? I should, because they're supposed to be congruent. Number 9. Justify the last 2 steps of the proof. Given that PQ is congruent to SR and that PR is congruent to SQ, prove the triangles are congruent? Well, we got our given statements. How do I know QR is congruent to QR? Reflexive. And so how do I know the triangles are congruent? Side, side, side.
Wait a minute. What? What about flexive and this?
Got it? 10, find the values of X and Y. Now look at that picture. Look at the big picture. What do they tell you in the big picture? Focus on the big triangle. What kind of triangle is that? What kind of triangle do we have? Isosceles. In isosceles triangles, the base angles are congruent. So if that one's 50, the other one's 50. If you've got 50 on either end, what does this whole angle at the top have to be? 80. And it is conveniently split in two parts. So each part is 40, right? And if you know that is 40, then if that's 50 and that's 40, what's left down here? 90. 10 says the octagon in the figure is equiangular. What's the word equiangular mean? All the same. It's regular. All of its angles are the same. What's the total number of degrees in an octagon? 8 minus 2 times 180. So we have 1,080. And then if you divide that by 8, each angle is 135. So B is 135 and A is 135. Now B is 135 and this little angle in here matches up with B to make a straight line. So can you tell me its measure? How much do you get? 45 degrees. Okay, so that's 45 right there. Now the statement here says AB is congruent to AC. So now what do we know about the triangle? It's isosceles. And isosceles triangles have base angles that are congruent. So if one is 45, what's the other one? So this angle over here is 45, okay? So now can I find the measure of this angle at the top? That's what I'm looking for, that angle. Well, if the bottom two are 45, together they make what? 90. And so that leaves how many left over out of 180? 90. So that is 90 degrees. Is that what they were asking? No, that's not what they were asking. They were asking for that answer. I'm sorry. They weren't asking you to find the one at the top. I took it one step too far. They were just asking you to find that. The measure of ACB is 45 degrees. 90 is the measure of BAC. They didn't ask for that. That's just extra information. 12. In an A-frame house, the two congruent sides extend from the ground to form a 52 angle at the peak. 52 degrees, okay? What angle does each side form with the ground? Two congruent sides, so these are congruent. So again, what kind of triangle are we talking about? Isosceles. If you've used up 52 degrees at the top, how many degrees are left out of 180? $128, and they're divided equally in an isosceles triangle, so each angle is 64 degrees. Two sides of an equilateral triangle have these lengths. Which of 10 minus x or 6 could be the length of the third side? Okay. Equilateral. What does equilateral tell you? What does equilateral mean? Does anybody in the room know?
All sides are equal.
All sides are equal. So, 2x minus 2 must equal negative 3x plus 18. Do y'all agree? So help me find x. Okay, keep going. X is 4. So I'm going to take that and I'm going to plug it in. 2 times 4 minus 2. What's that? 6. Negative 3 times 4 plus 18. What's that? 6. Okay. The question is, we have 10 minus x or 6x plus 6. One of these is the third side's equation and one's not. For it to be the third side's equation, when I use 4 in place of x, what am I supposed to get? 6. So which one works? 10 minus x is my answer. So 10 minus x is the answer for 13. 14 says, what additional information do you need to prove the triangles are congruent by hypotenuse leg? Remember, in right triangles, all you need is to know that the hypotenuse and a leg are congruent. You have to know it's a right triangle. You have to have a right angle. And then all you need is the hypotenuse and a leg. Well, in this particular drawing, they've given me the hypotenuse of each triangle congruent. So one answer would be AC is congruent to DC. Okay? There are other possible answers. That's just one of them. So you just need to prove that a leg is congruent. 15.
Wait, what's number 14?
AC is congruent to DC. 15. Which overlapping triangles are congruent by angle, angle, side? What'd y'all get on that one?
I was just guessing. I had no idea.
Okay, let's look at these overlapping triangles. How many triangles are in there? 3, right? 4? Do you see 4?
The big one.
Okay, I'm going to sketch out this one. A, C, D, and I know that that's a right angle. Okay, now I'm going to sketch out this one. B, C, E. Now let me ask this question. Is this angle C right here used in both those triangles? So mark it because it's congruent to itself. So what they asked me here, ADC and EBC? But they said use angle, angle, side. Is there any way I can use angle, angle, side with these two? We know that this is a right angle and it's congruent to that right angle. We know those angles are congruent. What do you know about those third angles, angle A and angle E? Do they have to be congruent? Yes, because of the third angles theorem. So these are the two triangles that are overlapping that are congruent by angle, angle, side. 16, write the missing reasons. AB is congruent to CD. I'm gonna
ask for it.
AB and CD. I want to make sure you know. Angle A is congruent to angle D. AF congruent to DE. Okay, we got it marked. Angle it says AF is congruent to DE given. Angle A congruent to angle D given. AB congruent to CD given. AB's measure is equal to CD's measure by the definition of congruent segments. This is the number 5. Number 16 is the addition property of equality. If you add the same thing to both sides, you get the same thing. Now, how do I know that AC is equal to BD? I use the segment addition postulate. Now, tell me about BC. Tell me about segment BC right here. Do you believe that BC is used? Is BC congruent to itself? Yes, and it's not by reflection. It just is. It's itself. It's used twice. If you add the pink BC to AB, you're going to keep the equality of adding it to the CD. That's what they're trying to say there. Now you can say that that segment from A to C is congruent to the segment from B to D. Okay? Definition of congruent segment. So now these are congruent by side, angle, side. (17) Explain how you can use these to complete the proof. Given ON is congruent to OP and NOM is congruent to POM. What else do you know about this picture that's not given but that you know for sure is congruent? Okay, OM is congruent to OM by what property? Then what can you use to prove the triangles are congruent?
OM equals. OM equals.
What reason are we going to use to prove they're congruent? But we're trying to prove, so NM is congruent to
That's what we're trying to prove.
PM. So what can we do for that? John, here you go. Corresponding parts of congruent triangles are congruent. So you got to prove the triangles are congruent, then you can prove that their parts are congruent. 18, complete the statement. BF is congruent to what? Okay, look at this triangle. And this triangle. Do you believe that DF is congruent to itself? So would that prove the triangles that are colored pink are congruent by side, angle, side, and side, angle, side? So then BF would have to be congruent to which other piece? FE. 19 says in ABD is congruent to CBD by HL. Is it congruent by HL? Okay, we know that DB is congruent to itself by what property? Reflexive property. So we know these are right triangles. Do we have a hypotenuse and a leg? Yes. Name the leg. We just named it. It's DB. 20. Write the missing reasons to complete the flow proof, given that ADB is congruent to CDB, or right angles, and angle A is congruent to angle C. Prove, okay, what other piece am I going to use? I'm going to use BD is congruent to BD by reflexive. Is that in there somewhere? What reason are we using here? Those two are given, and that's given. So I know that this is a right triangle. That's the definition of a right triangle. Angle A is congruent to angle C, given. That tells you that this side and this side are congruent because of the isosceles triangles. Therefore, the triangles are congruent by angle, angle, side. Right? I could say, they say side. DB is congruent to DB by reflexive. Angle, angle, side, angle, angle, side. Okay. Name a pair of triangles in the figure and state whether they are congruent. Given that BD is congruent to CA and AB is congruent to DC.
What?
Now look in that picture. Is there a side of these triangles that's shared? Is AD used in both?
What's A on 20?
I'll go back in just a second. So AD is congruent to AD by reflexive. Therefore, the triangles are congruent by what? Side, side, side. Here you go, Colin. Definition of right triangles. Everybody good? Let's draw these out. 22. RST UVW. R is congruent to U. ST is congruent to VW. And S is congruent to V. How can you prove they're congruent by angle, side angle? How can you prove these are congruent by angle, side angle? I got the, do I have them? They don't want you to use angle, angle, side. They want you to use angle, side, angle. So what are you going to have to do before you can say angle, side, angle? Angle W needs to be congruent to angle T by the third angles theorem. Then you can use that statement. 23, complete the proof. ON is perpendicular to NP. There's a right angle right there. PQ is perpendicular to QO. Right angle right there. ON is congruent to PQ. So what else do we know? What do we know about these angles? Why are they congruent? They're vertical. So we got our given, we got our right angles because they're perpendicular segments. How do I know that ONP is congruent to PQO? That is because all right angles are congruent. That is your reason. OP is congruent to OP. How do I know that OP is congruent to OP? Because of the reflexive property. The triangles are congruent now because I have a hypotenuse and a leg. And the triangles that we're talking about are PNO. And OQP. Okay, we're going to stop there.